Hello everyone. Good evening guys. Good evening. Okay, so audio and video is clear from my side. I hope it is clear from your side as well. Okay, so good evening everyone, and in today's session we will take some questions on Nyquist plot. So till this session we have discussed about Nyquist plot, and in the Nyquist plot we have seen the method, the basic method, the mapping part, how to do the mapping, and then we have analyzed the direct rules also, the direct trick also. Now I have taken some 3-4 questions on Nyquist plot, and these questions are BYJU'S, previous year questions. I have not taken the newly framed question, but during the session I have given you 2-3 newly framed question that are related to the concept. Okay, so in today's session we will discuss about these questions which I'm taking right now. Okay, so let's first cover the introduction part, and then we will try to solve the questions. Okay, this is my introduction. My name is Asu Jangda, and I teach almost every subject in electrical engineering. So you can join BYJU'S exam prep platform, and you can start your preparation with me. Okay, there is free scholarship test which will be on 23rd of July at 9 p.m. So you can register for it, and you can get the scholarship up to 90%. Okay, so you can register it, and the link of this registration is given in the description. So you can go to the description down there and you can register for it. There is free workshop which will be on 25th of July at 7:30 p.m. This workshop will be taken by Dheeraj Sardana sir, and in this workshop you will get the in-depth preparation strategy for GATE 2024. Okay, so this strategy you will get in this workshop, so you can join this workshop, you can recommend to your friends also. I hope you'll be benefited from this. So it's now it's time for the Guru Dakshina, and the Guru Dakshina is you have to subscribe our channel. Don't forget to like this session and press the bell icon so that you get the notification whenever my sessions are live. Okay, so guys, let's start the session, and the first question in this session is on your screen. You can see that the complete Nyquist plot of open loop transfer function GSHS. So we have open loop transfer function GSHS of a feedback control system is shown in the figure. So the mapping is shown. Okay, the mapping in GSHS plane is shown in the figure. It means we don't know the S-plane contour. The S-plane contour will be like this. It can be like this. Okay, I mean the orientation. It can be like this, or you can change the orientation also. It can be like this. I don't know the orientation. I don't know what is the orientation. So orientation can be in any direction. So it can be either this direction or this direction. So let's say we'll take both the cases. Okay, so the orientation of S-plane it's not provided, so I have assumed the orientation in 2 ways. Okay, and the mapping is given in the figure in GSHS plane. It's shown. The GSHS has 1 0 in the right half of the S-plane. So GSHS has 1 0. It means the 0 of GSHS is given to you. It has 1 0 in the right half of the S-plane. The number of poles that the closed loop system will have in the right half of the S-plane. We need to find the number of the poles of the closed loop system that are lying in the right half of the S-plane. Okay, perfect. First of all, look at this mapping. In this mapping, first let's look at the encirclement of origin. This is GSHS plane, and I am looking at the encirclement of origin. So if you are looking at the encirclement of origin, then the number of encirclement is 2. One is this and one is this. Okay, so there are 2 encirclement. Okay, so now I have to write 2 is equal to Z minus P or P minus Z. Z minus P or P minus Z. Okay, P minus Z. Fine. Now if you put Z equal to 1, because you know that this P and Z are the poles and the zeros of GSHS in the right half of the S-plane, because you are looking at the encirclement of origin. Okay, it is given in the question that Z value is 1. If Z value is 1, what does it mean? If I put Z equal to 1, from here you will get P as minus 1. So obviously P cannot be negative. So I am not going to use this formula. I am going to use this formula. So if I put Z equal to 1 here, then P will be equal to 3. It means the number of poles of GSHS in the right half of the S-plane are 3. The number of poles of GSHS in the right half of the S-plane are 3. We got this point. Okay, GSHS. Remember, we have found the number of pole of GSHS in the right half of the S-plane. That is equal to 3. Now it's time for -1. Now it's time for -1. Now you can see that the number of encirclement of -1 is 1 crossing is on this side and 1 crossing on this side. So net encirclement of -1 is, tell me, what is the net encirclement? Net encirclement of -1 is 0. So that will be equal to either Z minus P or P minus Z. Any formula you can apply. So from here you will get P is equal to Z. And we are interested in Z because we need to find the number of closed loop poles. And the number of closed loop poles are the zeros of 1 plus GSS. Since you are looking the encirclement of -1, so this Z and this P are the poles and the zeros of 1 plus GSHS. And we are interested in the zeros of 1 plus GSHS. To find the zeros of 1 plus GSHS, we need the poles of 1 plus GSHS in the right half of the S-plane. That we already know. The poles of 1 plus GSHS and the poles of GSHS are same. So we know that 3 poles of GSHS are already in the right half of the S-plane. So you can put it here and Z value came out to be 3. Because the poles of GSHS and the poles of 1 plus GSHS are same. So I can put P is equal to 3. So I'll get Z equal to 3. Z is the zeros of 1 plus GSHS, and we know that the zeros of 1 plus GSHS are actually the poles of the closed loop system. It means for a closed loop system, 3 poles are lying in the right half of the S-plane. So answer is 3. Answer is Delhi. This was a very classical question. This was a very good question, guys. Maximum student have done it wrong. Maximum or maybe 99% student have done it wrong. It was GATE 2021 and I remember this question. This question was very beautiful. Okay. So please be careful and you can understand the question like this. Okay. Let's come to the next question. In this question, the polar diagram of a conditionally stable for open loop gain K equal to 1. So for K equal to 1, the system is shown in the figure. Okay, this is the polar plot which is provided to you. The open loop transfer function of the system is known to be stable. It is given that the open loop transfer function of the system is stable. It means GSHS has no poles. GSHS has no poles on the right half of the S-plane. So P value is 0. P value is 0. Okay. Now we need to find the value of K for which the system is stable. Obviously, this polar plot is for K equal to 1. If you take K as 2, these points will get doubled. If you take K as 3, these points will get tripled. So what I can do is I can multiply these points with K. Okay. So these points depends on the K value. And we know that the number of poles of GSHS in the right half of the S-plane are 0. Number of poles of GSHS in the right half of the S-plane are 0. Now, if somehow we can get the PW value, what is the PW value? PW means number of poles on the imaginary axis. If somehow I can calculate the number of poles on the imaginary axis. Since you can see that this graph, I mean, this is a, you can say it's a type 1 system. Because when omega is 0, it's infinite distance from the origin. By default, you have to think like that. Okay. So what you can do is, you can imagine that it's a type 1 system. So PW is 1. PW is 1. You have to think like this. Okay. PW is 1. I hope it is clear. So we find P and PW. Now we need to check the stability. For what value of K the system is stable. Now how to do that? If you remember the 511 method, using that method, you can solve this question. This question is easy and you can apply that 511 method. Let's say -1 is somewhere here. If I take -1 here, obviously if -1 is here, it means -0.2 is less than -1. So from here 0.2K is greater than 1. You can write it like this. You can, and k greater than 5. If I take k greater than 5, let's first look at this case. If k is greater than 5, k is greater than 5, this case I'm taking, or k greater than 5, this case, or okay, this case I'm looking. So -1 is here. If k is greater than 5, -1 will lie here. And if you vary from omega infinity to 0, the arrow will be like this, because I told you in phi 1 1 method, you have to move opposite. Now, can you tell me what is the net phi 1 1? So net phi 1 1 is, it is going like this. Okay, you are moving anti-clockwise. So from this point to this point, phi 1 1 is 180. Now from this point to this point, phi 1 1 is 0. Again from this point to this point, phi 1 1 is 0. And now from this point to this point, phi 1 1 is anti-clockwise again, and 90. Okay, so it is 270. Now if you remember the previous class, for 270 the system was unstable. Okay, if phi 1 1 is 270, or remember, if phi 1 1 came out to be positive, always remember, if phi 1 1 is positive, system will always be unstable. So this is unstable system. Or you can apply that formula, that p minus z minus p, you can write it like this, z minus p minus pw by 2 into 180. Using this formula, you will find that z will be some positive number, system will be unstable. So at this point, system is unstable. So this cannot be the correct answer. Okay, this cannot be the correct answer. Now let's come here. Let's say -1 is here at this point. So let me erase this point. Okay, now what I'm taking is, I'm taking -1 to be at this point. It means k is less than 5, k is less than 5 and greater than this point. K is greater than half. Okay, k is greater than half, less than 5. Let's look at this range, in this range. So which option I'm asking? I'm looking at this option, or A option, because A option is also k half to 1/8, and half to no, A option is not this, no. In A option the range is different. So this range is only in B option. Okay, so let's see this range. In this range, whether the system is stable or unstable. So let's calculate phi 1 1. From this point to this point, phi 1 1 is 0. Now from this point to this point, phi 1 1 is minus pi, minus 180. Now from this point to this point, phi 1 1 is 0 again, and from this point to this point, phi 1 1 is plus 90. I have done in the previous class. So it came out to be minus 90. Phi 1 1 is minus 90. So what you can do is, you can apply the formula, minus 90 is equal to z minus p minus pw by 2 into 180. So you can calculate z is equal to 0. The system is stable. So in this range, the system is stable. So in this range, system is stable, and this range is only in B option. No other option can take this range. So answer is B. No need to check for k less than 1/8. Okay. So this way you can check it. I have taught you about phi 1 1 method. You can apply that method. Okay. And directly you will get the answer. I hope it is clear, everyone. Okay. Let's come to the next question. The next question on your screen is, the pole zero map of a rational function GS is shown in the figure. Okay. GS is shown below. The pole zero map. Okay, pole and zeros of GS are shown in the figure. Okay. When the closed contour tau is mapped into GS plane, okay, this is the S plane contour. And now we want to map this S plane contour into GSHS. We want to map this S plane contour into GSHS. Now we need to calculate the number of encirclement of origin. If we want to map this S plane contour into GSHS, then how many number of encirclement of origin will be there, and the direction of the encirclement, that I need to calculate. So if you look at this contour, inside this contour, 2 poles and 3 zeros are lying inside. So if you map this in GSHS plane, if you map this S plane contour into GSHS, then the number of encirclement of origin will be equal to either Z minus P or P minus Z. Whichever give you the positive answer, that formula you need to apply. Now this will give you the positive answer. So that's why Z is 3, P is 2. So number of encirclement of origin will be 1. Okay, we found the number of encirclement of origin. It's 1. And the direction of encirclement, since Z is more than P, The direction of encirclement of origin will be in the same direction. Same means the contour direction. The contour is you can see that it's clockwise. So if contour is clockwise, the number of encirclement of origin will be 1 and it will be clockwise. So that's why the answer has to be the origin of GSS plane in ones. Okay. So the mapping encircle the origin of GS plane once in counterclockwise. No, it's not correct. Okay. The origin of GSS plane once in clockwise direction. So that's correct. Okay. That's correct. I hope it is clear, everyone. Sir, I am getting IIT Roorkee Photonics and IIT Power Electronics. I think both are fine. Both are fine. Okay. Photonics is fine and Power Electronics is fine. So you can opt anything. Okay. Okay. Okay, guys. So I told you about this concept. So it's very simple, and this was a very good question, and I hope you understood it. Now, can you tell me how to check the mapping of -1? No, you can't check it. Okay. You can't check the mapping of -1 here. Why? Why can't you check it? Because we don't know the contour in GSS plane. We don't know the exact contour. We don't know whether -1 is outside or inside. So we can't comment on the encirclement of -1. Okay. That's the main problem. So we can only comment on the encirclement of origin because we are mapping into GSS plane. So we can comment on the mapping of the, you can say, we can comment on the mapping of GSS plane only. Okay. I hope it is clear, everyone. So now, I think I have taken only these 3 questions. So I hope you enjoyed these 3 questions. These questions were very good, and I hope you understood the concept. So that's all for today's session, guys. And please like our session and subscribe our channel. Okay. And there is our mobile app. So please install this mobile app. There also I'm taking free classes. So please join our mobile app also, and you will find some free classes there, and you can get benefited from that. Okay. So that's all for today's session, guys. I hope you enjoyed, and see you in some other session. Thank you and take care. Bye.